Hello, this video is a combination of 9.1 and 9.2 from the Larson book, Correlation and Linear Regressions. I guess you can say it's the greatest hits of those two sections. I'm not including things that we would have to have knowledge later on in the course to be able to use. So anything that's, if you happen to look at the book, anything that's not in these notes is not relevant. So I would stick with this, your guideline. You can still use the book to supplement it, but if you see things in there like hypothesis testing and stuff, we haven't done that yet. Anyway, regression analysis, it's a statistical technique where we're looking for a potential relationship between values where we have X, Y, we have paired data values now, not just an individual set of values. You have each X goes with the Y, so one data point would be two values, just like your XY coordinate system. And the Y is the dependent variable, and the X is the independent variable. So it's also known as the predictor. The Y is the response. So we're looking up to come up with this, what's called regression model, prediction equation, least squares line. It has several names. It's where it's a line in the form of y equals mx plus b, and you're trying to use x to predict y based on the relationship of the variables, which we'll talk about first, involving something called correlation. A correlation is a relationship between two variables, x and y. The data is represented in ordered pairs, I was mentioning, where x is independent and y is dependent. All right, so now sometimes you can get correlations between variables that really wouldn't make any sense. I'll talk about that here in a minute. Let me come down here. A scatter plot is collecting all your data, XY data, and plotting it, in a rectangular coordinate system, and looking at the relationship. Now you're looking for a linear relationship, so the dots are kind of clustered into a line shape. Granted, it's a thick line, and this is called a positive linear correlation, meaning that the slope of the line is positive. It doesn't matter that you can see that some of the values x and y are negative. That's irrelevant. It basically means slope being positive, because as x goes up, y goes up. And negative linear correlation, kind of where the dots cluster into a line heading downward with a slope negative, meaning that as x goes up, y goes down. Now dots all over the place. You can see this is just really spread out. No relationship, no linear correlation whatsoever. And then we're not studying this in this class, but this is an actual thing. If the dots form a shape like this does, it forms sort of like a parabola, a curve. It does have a relationship, but it's non-linear correlation. So that can be studied separately. We're not interested in that. We're only interested in linear relationships. Okay. Now here's an example where I just made up where x is the number of hours studied for an exam, and y is the grade on the exam. Let's see. And just made these up, gave up, and so each one you read them. 16 goes with 100, 8.5 goes with 76. So you can see I used Excel to graph this, and that graph is known as a scatter plot. And scatter plots, let's see, I mentioned, right there, it's scatter plot. Scatter plot was actually earlier in the book. I didn't cover it at the time because it was with the other graphs and things that we did, but I just assumed, waited, save it to here, and I figured that was the best time to introduce it, because this is when we were going to use it anyway. So, all right, so you see that's the plots form a nice little line. That line, we're going to talk about that. That's the line of best fit, also known as the regression line. It's mathematically calculated. It's not like an approximation of what you think the best line is. It has a mathematical meaning to it. In fact, even though, okay, we haven't looked at the equation yet, but I'll just go ahead and mention and what it is. Like I said, it's the line where if you measured the vertical distance from each point to the line. Well, these are all real close. They're bad examples. Here's one. It's kind of if you took all the distances and squared them, the line of best fit is the one that minimizes the sum of all those squared distances. And it's all mathematical in the way it's figured out or whatever. So it's not like you have these dots and you just take like a straight edge. You just try to guess what the best line is. No. It's fortunately we're not involved in the heavy mathematics. We'll have technology that come up with that line. But I just want to mention that it's not just an approximation. It's a mathematical baseline. All right, nothing else left on that page. Maybe oh well. Cleaning these notes up, I guess I left a little gap in there, took something out. Now here's a measure for correlation coefficient. It's known as lowercase r, and it's a number that's between -1 and 1. -1 is what we call a perfect negative relationship, linear relationship. That means the dots would form a complete straight line, perfectly straight line. Doesn't mean the slope's -1. It does mean the slope is negative, but it could be a little flatter than, it could look, doesn't have to be that shape. It could go like, maybe like this. Of course, I'm trying to draw this, pretend like this is going to be a straight line no matter what it looks like, but of course you have to pretend my other one's straight too, so. Yeah, you see, that would be the same kind of idea. It just doesn't have the same slope, but it's a perfect negative linear relationship. And same thing goes with the positive side. It's for perfect correlation of +1, that means the lines form a straight line, perfectly straight line with some sort of positive slope. Now, the idea behind this measurement is actually the strength of a linear relationship. It actually gets stronger towards -1 and 1. -1 and 1 are both perfect linear relationships. They just have different slopes. So one's going down, one's going up. Those are both perfectly the same. They're the same strength, in other words. So actually in a correlation coefficient, the weakest correlation you could possibly have is 0, and it gets stronger as it gets out towards each end. And I mentioned about 0 right in here. So if you're comparing like this, which is the stronger correlation, I believe there's one of these in the homework problem. I'm gonna skip it, because I think you'll be able to handle it, no problem. But actually, it just says stronger. It doesn't say stronger positive, stronger negative. Stronger means the closest to the end. In other words, -0.8 is closer to -1 than +4 would be to +1. Another way to look at it is if you just take the absolute value, the bigger absolute value also proves it. So the absolute value of -0.8 would be +0.8, so that makes it the stronger correlation. Calculating the correlation coefficient. All right. Of course, technology is going to be our friend here. And the Excel command is coral array 1, array 2. And the order doesn't matter here. We'll see that in one of the assignments coming up here. But something else we're going to be doing here in a little bit, the order does matter. In other words, it doesn't matter whether the X's or Y's are first. But I did it with the X's first. So you just pretend like, this is your A1 cell right here. So it's CORREL, and then that's A2 all the way down to A7. And the Y's over here in B2 to B7. And there's these where I did the formula. Obviously, that's the formula text, and here's the result. That's a very, very strong positive correlation. And we'll do this. We'll do this coming up. Another example, but you can see that right now. But we'll watch it happen. Certainly, like with the homework. Now, one thing you may have heard the phrase before that correlation doesn't imply causation. And what that means is, if somebody's studying this kind of statistical analysis and correlation and linear regression. It's sometimes you can get strong correlations on things that wouldn't make sense that they would have, one would cause the other. What do I mean that? Let's take a hypothetical situation. Let's say that the Y value was exam grade, but the X value was shoe size. Shoe size and the exam grade. And let's just say, suppose by accident, by calculation, that turned out to be like a strong correlation. Well, that's where common sense comes into play and says, wait a minute, there's no way shoe size is going to be a factor in reality involving exam grade. So that's something to kind of keep in mind. So, hey, it has a strong correlation. It doesn't always mean it's going to make sense. Now, obviously, this makes complete sense. Your hours, exam grade being a function of hours studied, that totally is logical. The more you study, the better you should do. Okay, just thought I'd mention that. Now the TI-84, I don't know if you're using one of these online Wabbit EMU calculators, if you have to worry about this, but I'm going to show you on this online calculator how to do this just in case. It's weird, you have to do this thing, and I'll show you how to do it. And you have to do it, let's say if you were going to have to reset the memory in the calculator or change batteries, you would have to go back and do this again. Otherwise, turning the calculator on and off wouldn't affect that. So if you're using a physical calculator, keep this in mind. I don't think online, I don't think you may have to set it up once online. Mine was already set up, but you do it, just see, and you shouldn't have to do it again. But you would in this class if you were having to change batteries during the semester, so if you're using a regular calculator. So it's not too big of a deal. You go second 0, which brings up the catalog. And it's this diagnostic on we're looking for. Now you can see you can scroll all the way down, but here's a little shortcut. If you go alpha, and then there's the D right there, the green D right next to matrix. You hit that, and it, okay, alpha, D, and it just jumps you to the D's. You could do that for if you were looking for a specific function. I thought you could have just scrolled, but this actually, okay, I'm looking for that, diagnostic on. I never care about diagnostic off. I do that, done, and then and that's it. We've got it ready. Okay. So I'm going to put this one in the calculator, though. I want you to see this, especially since it's not there. But it's telling you what, you're going to watch me do it, but it's telling you what's going on here. So we're going to put the X is in L1 and the Y is in L2. So I want to go clear, stat, edit. We'll come over here, clear, come over here, clear. So I'm going to show you how to do this, but you're going to see as we go on. I mean, you can remember, you can always use whatever you want, but I'm going to be using Excel, especially when it's dumping the data down for us in Excel. Like, on a test, you questions, you'll see the data there. If you have to enter it into either calculator or Excel, then you can choose what you want to do. But if the numbers are already in Excel, it kind of makes it hard to justify to put them into the calculator. But if you want to, that's great. But now once you see how to do this, you'll be fine if you need to or want to. 10, 3, 6, 7, 8, 4. And we have 96, 64, 80, 76, 92, 60. I'll go second quit. And you see down here I have the, I just didn't show the data screen's not showed here, but that part was shown. But here's the command. which I'm going to do it anyway though here. So you can at least see that. So if you want to use this later, and now you got to is enter the numbers, then do what I'm about to do right here, which is right here in the notes for you to refer to. Stat, calc, number 4, linreg. L1 is X, L2 is Y. Just go all the way down to calculate, hit enter. And now you can see on the screen is everything that's on the screen in the notes. And there's the R right there at the bottom, 0.9416, blah, 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 which is exactly what it was in Excel up here. Right there. All right, so there's how we do it in the calculator. Now we have what's called the simple linear regression model. And this is if we were talking about a population. It's kind of using the Greek letters here. And I just left that in there, but we're not going to have to worry about it. The error terms, it explains what the error terms here. Essentially, if you're using sample data to approximate a population, there's always some sort of built-in potential error there. And we'll talk more about that in the third unit, not for this, but just in general of using sample data to approximate population. Last branch of the course is called inferential statistics, and that's what we'll be doing. But here's what we want right down here, the least squares line, also known as regression line. This is called y hat, and in many books it's written this way, equals b0 plus b1x. I think the reason for that is because we're not studying in this class, but there's a thing called multiple linear regression where you're using more than one different x value to predict a y. So you would have like b1 x1, b2 x2. I guess at that point it really wouldn't be linear in the sense you couldn't graph it as a line, but still. But mathematically, it's basically this idea here from algebra: y equals mx plus b. But I think that's the reason why they write it like this. So just be careful, because you could have questions, whether it's homework or exam, where it could be the other order. Just this. So that means the b1 is the same as the m, which is a slope, and the b0 is the b, which is the y-intercept. So you'll see how I have these answers written both ways. Show you. You'll see here in a minute. Now in the calculator, I'll just turn this back on. It should still be there. Yes. So the same thing we did by entering the data and doing the calc linreg. It gives us correlation coefficient, but also gives us the value of the slope and the y-intercept. Now the calculator uses y equals ax plus b as their equation. Same thing. So that means a is the slope, and then b is still the y-intercept. So you see I labeled it using the b0 and b1 notation. b1 would be the same as a, b0 would be the same as b. So you can write this equation or see it written as one of two ways in the sort of the y hat traditional form. It'd be 44.56, the intercept value, the b0, plus the 5.28, which is the slope, x. So you see, whatever the slope is, it must stay attached to x. So even if you write it in this order, y hat equals 5.28x, the slope stays with the x, and then plus 44.56. All right. Now, you can predict values for y based on x that are within the boundaries of the original x values. It's not valid for anything outside the original values, and you can predict a value that's even already in your list of values, but it has to be within the range. So you could say, where are they? Yeah, in other words, we could predict it for 7, even though we have a value for 7, but it needs to be something in here. So this was one example of one person who studied 7 hours and made 76. What the equation is trying to tell us is what would be just on average, what would you predict for a person that studied 7 hours? What would you predict their score to be? And that's also the same thing as saying as you're expecting that to be the average of all scores for 7 hours. Same thing, same idea. And we could put 7. I didn't do 7. I think I picked a different one here, but I could put 7 in there to show you real quick. Let's see what I got another. Oh yeah, well 7's coming up right down there. I knew 7 looked familiar. So you gotta stay within your values, because you can say, hey, what if I study 100 hours for this test? Well, you put 100 in there, it gives you 528. Yeah, if I study 100 hours, I'll make a 572 on this exam. Well, that doesn't sound too accurate there, does it? Tell somebody that, they're going to tell you, okay, you might want to lay back on the bottle of wine a little bit there, whatever. But yeah, so you can't just pick any number. It's got to be within reason of your values. And 8.5 certainly fits in there. So we put 8. It's real easy calculation. You just take the equation and then just put in 8.5, and you can use Excel. You can go equal, but calculator's good enough. Just go 44. Yes, there's not a special built-in function for this, but frankly, there doesn't really need to be, because it's easy. Actually, I am going to show you a little trick in Excel. I could also do the same trick here, but I don't think it's really worth it here. It'll be easier in Excel. And there it is. There's your 89.44. Now here's this. I'm showing you the window. I did a scatter plot. I can show you this real quick, and then I had to put the equation on the line. And you're not really going to do this in the calculator, but I'm sure somebody's probably thinking, out there in cyber world, hey, I want to see that. So all right, I'll do it real quick. But we're going to use Excel for homework purposes. So I'm going to change the window to look like this. Okay, it's already there because I've already done this. And yeah, it's just where everything will fit in the picture. See, it doesn't automatically fit unless you get the window right based on the values. And you see the Y values are higher numbers, those test scores. So I had to make it appropriate there. And then Y equals, there's the equation. And let me quit out of that for a second to show you something. Go second, stat plot. That has to be turned on for it to graph. So I'll go quit out of it. So I already turned that on. So it should, that way it'll draw the line. It'll graph the line for the equation and then graph those dots in there. The scatter plot dots. Looks like I'm using a different symbol here for some reason. I must have changed it to little baby squares versus little plus signs. That doesn't make any difference, obviously, but. And there it is. So that, that line, there's your line of best fit that goes with that scatter plot. All right. You can do that if you want to, but you don't have to worry about it. Now, using the Excel commands. Slope. Okay, that gets you your B1. So pretty basic wording there. I like that. Intercept. That's your B0, which is your Y-intercept. But here's the key. I got this mentioned in red. You have to put the Y values in the command first, then the X value second for both of those commands. Now the calculator is just the opposite. Calculator, they want the X's to be in L1, they want the Y's to be in L2, and they'll take care of it from here. But here, for some reason, I have no idea why it's done this way, but the Y's must be entered first. Okay. For correlation coefficient, that does not matter. And we'll see this with other ones coming up here. So I won't retype this one right now since I'll be doing fresh ones here shortly. But so I put in slope and then that starts 96 would be in B2, B2 to B7, comma A2 to A7. Same as the correlation, except their B's have to go first. Intercept B2 to B7, A2 to A7, and it got us the same values that the calculator did. 5.28 for the slope, 44.56 for the y-intercept, and there I wrote the answers, and in either order it could possibly be presented. You could have the intercept, the 44.56 could be first, or it could be last. So predict the grade, exam grade for a student who's studied 7 hours. We get 81.52. So, maybe this particular person maybe underperformed a little bit, but that's just it. We're all different people. We're not all going to do the same thing. Some people are going to do. That's why it's just kind of a prediction, or rough estimate. But more likely, it's a kind of an average of what people would do. So, but this is what we're saying based on this model. We expect them to make around 81.52. That's not a guarantee or anything, but it's just our prediction. So that's going to stop the lecture portion of the show here, and we'll get to the homework. I'm going to start with problem number 4 here. First 3 are pretty basic. I think you should be okay with those. Here's where we get to the real calculations. So let me come over here and click that little box that gets our data for us. All right, enable editing. All right, what did oh. No, I did something wrong. Or did something to take the data out of view. I don't know what I did. Well, I don't know what I did wrong, but so I paused the video and reloaded the data again. Somehow I wiped it out, so it's all right. Just give us a new example. And wants us to do the correlation coefficient. I believe it said with row 1 be x, row 2 be y. All right, did this earlier, so I'm going to copy this right here. Over to right there, and let's see what that looks like. And let's see, so negative, let's see what it wants, how many decimals it wants. 3, I think. Negative 0.234. Perfect. Now I'm going to go back in Excel and show you this, but as I told you before, you haven't actually seen it yet, but now you'll see me show you, but I told you it did not matter for this, so I can go ahead and just put the answer, same answer right in there. Oh, the negative, get the negative in front. But let me show you just to, well, obviously I think you're probably convinced now that that's correct. You can kind of see it right here. I'll copy this over to our spreadsheet. And you see I reversed the order of the x's and the y's and correlation coefficient, and it made no difference whatsoever. But for the slope and the intercept, it was a huge difference. Well, it is a huge. We're not. We're not going to be switching them. remains unchanged. That would be the answer for that for sure. All right, let's see. So I think I did a couple of these next problems here. Let's see. Let me look. Okay. Let me look at the show completed here. Oh, okay, that's just correlation coefficient, so I'll leave you alone with that one. But the ones I did were, let's see, looked at before, I think were 2 out of the last 3 or something like that, because they have all kinds of fun stuff in them. Hours test score, we've already done that. That's kind of boring, but good practice for you though, obviously. But all right, so this looks like a good one. Yeah, I think I've seen this. Heart rates and QT intervals. QT intervals is a measure of electrical waves of the heart. I did not know that, but my nurses out there probably know that. Interesting. So we are trying to predict, let's see what it'll show us that, yeah, so we're trying to predict the QT interval based on the heart rate. Okay. So if you really, really want to do this in the calculator, you'd have to go through and manually enter those in L1 and enter the other was in L2. I mean, I love the calculator, but for this one, that's what I'm saying. The numbers are already here. It kind of makes life easier if we just do this. But hey, I'm just letting you know if you want to do the calculator. Okay, somewhere, doesn't really matter. I'll put the, well, this will be formula text. E2, because I'm going to do it to the right of me there. And I'm going to do, it doesn't really matter what I do first. I'll do slope. The y's go first. They are B2 to B14. And then A2 to A14. Yeah, you can see it's labeled slope now, so I'm going to drag this down. Now I'm going to do intercept. INTERCEPT. Once again, B2, B14, A2, A14. Not AQ14, A14. There's our intercept. So I don't know how many decimals it wants there. Let me double check. Let's see. All right. It wants 2 decimal places. So it was, I forgot, 2.06, is that right? Or negative 2.06, yes. and 2 decimals for the slope. 522.65. Hooray! Now, I'll show you how to do a scatter plot real quick in Excel. So I'm going to highlight these, insert charts. There's a bunch of dots. That's probably it right there. There we go. All right. So we can then, go and look and model, get the answer off of that. Now this one's actually, it's a little tricky because if you look, first of all, B and C are gone because they are going a positive slope, and we definitely have a negative slope. But I could go back and look at the graph, or I could copy these. But anyway, they both look exactly the same. The dots do exactly the same. Makes it kind of tricky because usually you'd be looking for one that had the correct shape. But where they tried to trick us here is the difference that makes the right answer is the scale of the axes. The X and Y axes are different. See those, come back and show you over here. See, these are kind of 650 to 100, and these are 350 to whatever, 500. See, only A. See, A has big numbers for the Y, medium-sized numbers there for the X's. So that A has them reversed over here. On graph D, has them reversed. So that's how they got a little sneaky on us on that one. Okay. Now there's a little trick I'll show you. I think we have to predict a few of these in a row here. So yeah, you see A, B, C, D. Not that it takes that long. You're just plugging these in, but it does say if the value is meaningful or not. And what meaningful is, what I talked about in the lecture, that it's got to be within your range of values. So let's look at 120 for the heart rates. No, 120 is not even close. So we choose it's not meaningful because it's outside the range of the data. Now the next three are all going to be in there. Now, and it's not hard, you're just plugging the x's, into your equation right here. So it's not difficult. But I'm going to show you something. You do this, you use this or don't use this in Excel. It doesn't matter. Let me get rid of this. And I'm going to put equal. I'll do this. It doesn't matter which order I do it in. I'll do the form, the way it defines it originally. And I'll use 2 decimal places like we had to round it to 522.65. So I'm using the B1, B0 plus B1x method. Plus, well, it just makes, I can put minus there since plus and negative is just minus. But now I'm going to put F. I'm in E5 right now. I'm going to put F5. Okay, that doesn't do anything yet. So if I come over here, that means all I got to do is for each 3 of those is just type in the value, do it, and it's going to calculate it for us there real quick. So I don't know if that helps or not. I just thought I'd show you that. So what's the first one? I think it's kind of slick, but it's okay if you don't use it. 68. So I come over here, put in 68. So I'll just type right over each one of them because we're going to be entering the answer. 382.57. Excellent. 90. I'll come over here and just put 90 where the 68 is. 337.25. Check. Got it. And 82. That'll be the last one for this one. I think we'll do one more. 353.73. Oh, so 353.73. Oh, now let me double check. Yeah. Got it. Okay. So I think there's two more questions left. I'll just pick one of these two. Calories and sodium. Let me just look and see if there's anything. Why won't it minimize those screens? Okay. I'll look at the show completed just to see if I think one of them has something in there special. Maybe the other one doesn't. Other than that, they won't matter too much. Okay, this is just a prediction. Oh, same. Oh no, it's not just a prediction. It's also got the scatter plot. All right, so. All right, we'll do. I guess this is fine. It doesn't really matter. Calories and sodium. I don't know if we want to do that one or whatever. All right, we can do this one, I guess. Yeah, either one's about the same thing, so let me get rid of that. All right, so we're looking to see if then sodium is a function of calories. All righty, so get my formula text in here. E2. And I'm going to we'll do slope first. The B's go first, B2 to B7. A2 to A7. There's the slope. And now we'll do intercept. Same range of values. B2, B7. There we go. So I'll assume it's two decimal places again. Of course, you know, Yeah, I always got to double check. You can't assume anything in here, but I can come back. It's no big deal if I assume 2 and I'm not right. So 2.55 will be the slope. Sure enough, I'm not right. Wow, I'm telling you, I thought it was 2, the other part. Yeah, that's what, you can't assume anything in this, can you? 2.546. And the y-intercept, 3 would be 32.631. Hooray! Scatter plot. Well, 2 of them are ridiculously stupid looking. Answer A and answer D. You know, the line's not even really going through the dots, so it's either going to be B or C. And they didn't try to trick us on the scale this time. So, but you see the scatter plots look different, so that's the key. This is good. The other one was good too. I like that where they reversed it. They tricked us on the axes, but now that won't be the issue. They'll have 2 different shapes, dot plots. So let's just dot plot them real quick in Excel. Or I'm sorry, the correct phrase would be scatter plot dot plots when there's only, technically we learn what that is. That's when it's 1 dot. So let's scatter plot them. Excuse me for not saying that correctly. And let's try to just kind of look at the pattern. I'll look at these 3 here and see if I can tell from there. I think it's B. Because C doesn't have those, yeah, where those 3 dots are kind of along the same line there. Yeah, I think it's this one. So you're just trying to get an approximation there. There you go. Now, before I scroll down, you see that values are anywhere between 80 and 180. So is there anything in here we're not going to be able to predict? 180 is okay. It's right on the edge. Yeah, so the last one, 210, that'll be the one we'll say it's not within the range of values. But we can do A, B, and C. Well, I'm going to do the same little thing I did in the last example. I'm going to get rid of this graph. I'm going to try and get rid of this graph. Well, okay, I can just super shrink it. That's good enough. So I'm going to do this thing where I'm putting the formula in there and just type the values in quick that way. So I'm going to say, and I'll use 3 decimal places like we did because it's probably based on, I'm not going to use all, it's basing the answers, I'm sure, what we put in that very first part. So, okay, I'll do it in this order this time. Doesn't really matter. I'll do this. So now I'm doing like y equals mx plus b. The other one I put the intercept first, but as long as the slope is attached to whatever your value is, and that's f5 plus 32.631. So I come over here to f5 and put in my 3 different values. $180. $490.911. It's interesting. This is a multiple choice one instead of typing the numbers in there. Interesting. That's fine. I'm just saying that's a little different there. Oh, we're checking them one by one here. Okay, all right. All right, got it. Okay, that's fine. So we sometimes may type them in. Obviously on a test it'd be multiple choice like that, but 100. So I go right back over there and type the 100 over the 180. 287.231. There it is. Okay, got to hit continue. 150. 414.531. Fantastic. And okay, this one's not worded like the other one, but that's good enough, not meaningful. The other one we had to pick the answer. It said, well, it's what's outside the range of values, which, yeah, that's correct. And that, outside the range of values tells us it's not meaningful. Got it. And all right, I think that's going to conclude our lecture on correlation and linear regression.